In our last class, we have studied up to this. We have seen that what are the design evaluation criteria for a programming language, and we have seen that what is readability. And today we will see the writability part. So readability and writability, they are both same thing. Some Most of the times, if a program is easy to write, it's also easy to read, but there are some cases where it's actually difficult. So let me give you an example that, so let's assume that you are using a programming languages that actually takes very few lines to code. Okay, now what happens when you have you are applying very few lines to code a large program? Is Most part of the program is abstract. That means if you know the syntax, you'll understand what happens here instantly. But if you don't know the syntax, then it becomes difficult to understand. Okay, so the writability is a measure of how easily a language can be used to create programs for a chosen domain. So the domains are, as we have talked about, are fine scientific domain, it can be a web domain, it can be for business application, and so on. Now, the first thing is that, again, is simplicity and orthogonality. So we're trying to use the same type of instructions everywhere. Okay, and we also want to use the simple instructions. So in the last one, the example that we have seen in the last slides, that instead of using multiple ways the count, we will use the same way. So that will be one way to make things simple. Okay, so we will be use one same type of instructions. And second one is that for the same purpose is support for abstraction. Now, sometimes what happens, we use complex structures to make our task easier. So whenever you are using a program, if you go to the GitHub and if you see the projects that are done by professional developers, you will see the code is very much what refactored. Okay, so if you're not still familiar with how the refactoring process works, basically it's a process that whenever you write a code, it does, it actually teaches you some rules that helps you to make your code more efficient. Okay, make your code clean, remove unnecessary parts. So whenever you write a normal code, what happens in that, sometimes we actually write some unnecessary if else, unnecessary nested loops, even though it could have been avoided. So refactoring, what it does, it actually uh, removes those part. Okay, now back to the topic is that sometimes if you go to the GitHub and see the code done with very professionals, what you will see that those codes, sometimes you find it very difficult to understand, because you'll see that they have done the task, and even if they have done the code in C or C++, the first problem that you will face, that you don't actually understand what that part of the code is, even though you know the syntax. Okay, maybe you're not familiar with the way it has been done. Okay, or even though you can see that this is a loop, okay, you are still finding it difficult to understand how this loop work. Okay, or what actually this loop is doing. So the reason is that instead of breaking it up in a simple step, they are using abstraction, or they are using a complex structure to make it more efficient. Okay, and you are not familiar with the complex structure. Same can be said in case of C programming language. So all of you are here familiar with C programming language. So what you can do, you can just go to the Google and search for some C sample projects, and you will see that some of the project you'll understand from top to bottom. They're very simple. Okay, some of the projects you will not understand. So for your first assignment, we'll start with a project that is yeah, that is a game that you, I think all of you have played. Then game name is Flappy Bird. Okay, so today what you can do, you can just search and see the sample code. It can be C++ or Python code for Flappy Bird. If you search there, you will see that the game is very simple, and the code, the line is around 1,000 lines. Okay, but still you might have a little bit difficult time to understand. In the end of the class, I will just show you how the Flappy Bird game works, in case you have you did not play the game. Okay, but this will be your first assignment, and we'll go to that now. So second point, okay, the programming languages can support two distinct categories of abstraction. Now, first of all, what we do, sometimes we break down the programs into small functions that we call subprogram. Okay, Now there can be sometimes what happens if you are breaking it into the different subprograms, you are actually making it more complex. Okay, then sometimes when the data flow is very difficult to understand, you are passing data from one function to another function, from that to another function. Okay, the process becomes very complicated. If you have developed a project on your own, you know the difficulties that you face. Okay, so even though this class inheritance, this type of hierarchies are abstractions are given for easier, to make your life easier, to give you more advantages, sometimes whenever the program is huge, okay, things gets out of hand. Okay, now to understand the writability a little bit more, let's go over this, the orthogonality. So first of all, what does the orthogonality means? Orthogonality means that in a computer programming, okay, whenever you want to do a task, like if you want to write a loop, there is a fixed syntax for, then I equals to 0, then there's a limit of the loop, then I plus plus the increment part. So if you want to write a function, there's a specific syntax. Okay, so these are called primitive constructs that can be combined in a relatively small number of ways to build the control and data structure of the language. Again, whenever you want to do a specific task, there is a set of tokens that you have to use, okay, to do that. Now the question comes that what is a token or what is a primitive construct? To answer that question in simple words that you will understand, that think about C programming language. So whenever the C programming, you write a program in C programming language, it starts with something like this, include stdio.h, that's the header file. So whenever we need a header file, we use include stdio.h. Now the include part, okay, that can be said that it's a token or it's a primitive construct. That means whenever the compiler sees include, it understands that I need to use the header file. Same way can be done integer main. Whenever the compiler sees integer main, it understands that, okay, this is where my program begins. Okay, then I can go on, like if you write return 0, the compiler understand this is where my program need to be finished or completed. Then whenever whenever you write a function name, okay, the compiler understands I need to go there. So that means there is a vocabulary, okay, that are defined so that you can understand, or the compiler understands that what it needs to be done. Okay, same way, so orthogonality means that whenever you are designing a programming language, what you will do, it will have a relatively small set of primitive construct. That means a function can be called multiple ways, but it will have a small set, that means a small number of options where you can combine in a relatively small number of ways to build the function. So the same thing that we have said before, that even though you have multiple ways to do the thing, we will try to make sure that you have a small number of ways. Like this, you can maximum do 2 or 3 ways. There cannot be 20 ways to call a function. Okay, it should not be. So that is the first terms that orthogonality comes in. It might be a little bit difficult at first to process, but don't worry, as we go through the chapter, it will be very much clear. Now the term is mostly frequently used regarding assembly instruction sets as orthogonal instruction set. Okay, now the more orthogonal the design, the fewer the exceptions. So that is something you have to remember. So the less option you have, we call it more orthogonal. Okay, if you have only one option, that if you want to call a function, this is the only way to do it. Okay, that means that's the orthogonal design. Okay, if you have 10 options to call a function, we will not call it orthogonal. Okay, because you have to remember the 10 ways, or even if you don't use the 10 ways, some other developer might. Okay, so the more orthogonal the design, the less option you have. Okay, and it makes it easier to learn, read, and write the program in a programming language. So try to remember this part, that this will give you the whole idea. Okay, so an example from IBM mainframe, let's go to the next slide. Look at this one. Okay, so this is the first one. What you can do, this first one, what it does, it actually adds two numbers that is stored into these registers, a register 1 memory, or what you can do, you can use the second one. So in the first case, the contents of register 1, okay, are added to the contents of a memory cell. So this is one. Okay, so this result is stored in register 1. So this is the first way to do it. In the second case, the contents of the register 1 are added to the contents of register 2, and the result is stored in the register 1. So you see, both are doing the same thing. adding the data from register 1 memory cell and this 2, and then storing them into the register 1. So they're both the same operation, but if you look at the instruction, first one is A, second one is AR. So what they're saying that for doing the simple add operation, what you have two statement. So one developer can use the first statement, another developer can use the second statement. But look at here. Okay, in this case, okay, you only have one statement, okay, addl, and using that statement you just have to write the operands. Now what is the difference? Difference is nothing, just a one statement difference. This is a simple example. The real example can be much uh, bigger than this. Okay, it can have a 20 option to add two numbers, and another language can have only one statement. So we can say that this one, okay, we can say that this one provides you with less number of option. Okay, so it's easier for the programmer to remember, okay, and it's easier programmers to use. That's it. So that's what the orthogonality is all about. Now going back to the topic, that what are the evaluation criteria for the writability. So whenever you are writing a code, okay, in any programming language, the code will be easier to write the code, it will be easier to understand the code for both the compiler and for a human reader. So as a human, it will be easier for you and also for the compiler. And that's where the refactoring comes in. If you get time at the end of the course, I will cover the refactoring part. But I think it will be covered in the software engineering course. So still, just to give you an idea, I will, if I get time at the end of the course, I will go through the refactoring. So it will actually make you a better programmer. So anyway, so what we do, we have to make the code not only easy for the human, but also easy for the compiler as well. Now look at these cases to understand the expressibility. Look at the case one. Okay, both of them are doing the same thing. They are printing a string that is hip hip hooray. The first one also prints it, the second one also prints it. Now if I ask you that between these two, okay, which one is more expressive, that means easier to understand, okay, so you will say that there might be a little bit thinking, okay, so what I'm looking at is 3 into times hip hip hooray. So if you look closely, you might understand, okay, so this is the loop. But if you don't see the example that is below, first it will take you some time to understand what the case one actually means. Okay, but when you see this, and when I say that both of them does the same task, you can understand, okay, so this is also might be easier. So what I'm trying to say, that between these two example, case one and case two, if you first don't look at case two, okay, you will, if you look at case two, you will instantly understand this is a loop, this is printing hip hip hooray 3 times. But the first one, it will take you some time to understand. Okay, you might not be sure as well. So what we're saying, that second one is easier to understand, okay, and it's easier to understand for the compiler as well. So sometimes what we do, we trade precision for expressiveness. That means this one is more precise. Okay, you see, I can say this is more efficient, easier to write, but this one is very uh, expressive. Okay, this you need more line of code, you need to type so many things, I equals to 0, I less than 3, I plus plus. Okay, but this one is just 3 times into hip hip hooray, so easy to write, right? So it's still sometimes what we do whenever we are writing a code, we use the following one so that it becomes easier to understand. Next is reliability. Now, before going to the reliability, there is one more thing, that is whenever you are comparing between readability and writability, one easy example is by comparing two programming languages that are not in the same. For example, if the last class I have told you an example. So if you compare between machine code versus if you compare with C, okay, every time C programming language will win, okay, because machine code looks something like this, okay, and C programming language looks something like this. So obviously we can say this is easier to write, this is easier to read, and so on. Okay, and the machine code is not easier to read and write. Okay, but the complicacy becomes if you want to compare between C++, let's say, and Java. Now, both of them, okay, between these two, If I ask you which one is more readable and which one is more writable, the question becomes difficult to answer because there is no specific way you can justify. Okay, there are some cases of C++ that are easier to read. There are some cases of Java that are easier to read, and the same case for the uh, Python and PHP and so on. Okay, so it becomes difficult to uh, find an exact difference between these programming languages, the higher level programming languages that we currently use, because all of these programming languages, they actually use the same design evaluation criteria. They always try to make sure that their programming language is readable, more writable. Okay, so they have these features, readability and writability. But still you can say that Java is uh, is better in terms of readability than C++. Why? So if you look at the Java code, if you have done the Java course, you'll see that in some part of the Java, we are trained to use more detailed instruction set. Okay. And we also, in case of Java, what we do, okay, whenever we're writing a code, okay, we tend to use less amount of primitive construct, that means orthogonality. So all of this operation actually makes it more a little bit, not all by lot. Okay, so if you compare by between machine and Java, Java wins by let's say 100 points. Okay, but if you compare between C++ and Java, Java might win by 10 points, 5 points. Okay, so that's very close. But the next points that we'll discuss, that is readability, right? Sorry, reliability and cost and portability. They will actually put Java a lot further. So before going to the reliability, let's come with a simple example, that is these three. Okay, so portability, generality, and well-defined. So what does portability means? Portability means that if you write a program for one platform or one type of devices, it can be moved to another type of devices or another platform. One simple example is Java. Okay, so you have heard about JVM, Java Virtual Machine. So what it does, okay, it doesn't matter for which machine you write the code, it actually compiles and interprets the code in a way. We'll also study about the compiler and interpreter in the upcoming slides, so don't worry. So just know that compiler interpreter translates the code in a way and it turns it into the Java bytecodes that can be run in any machine. Okay, but that is not the case for other programming languages. So some of the programming languages, they are portable. Some of the programming languages are totally machine dependent. That means for each machine, you need to write a separate specific codes, which actually becomes very much complicated. Okay, so for different machines, you have to write different code because each machine understand the code in a different way. Okay, but that is not the case for Java, which actually puts it a lot ahead of other programming languages, because if you write a program in Java, it will run in all the platforms. Okay, now what does the generality means? So generality means that you have to choose a programming language that can be applicable to wide range of applications. So think about the Python that I said in the last class. So if you are using C programming language, you know that we use C programming language for system programming. Okay, that means programming, it is needed where it's fast and lightweight. Okay, but C programming language cannot be used for web development very well. If you want, if you are a persistent developer, that sir, I will develop a web project in C. Okay, yes, you can do that. It's not impossible. Okay, there are ways you can do it, but it will be very difficult for you. Okay, just try to think about a simple graphics. If you want to develop a simple graphics in C, you will need a lot of hassle. Okay, so but if you do it in using JavaScript and PHP, your life will be much easier. Okay, so some of the programs, as you have said before, is actually domain dependent. Okay, but some of the programs that can be used for multiple domains. So you will always try to learn, or always try to use a programming language that is more general. So Python is one of them, right? Python can be used for web development. Python can be used for machine learning, AI. That is, both are, by the way, both are same thing. Okay, I don't know why people keep asking me, sir, what is the I'm not interested in machine learning. I'm in doing AI. So please try to be learn more about it. Just search YouTube video. You will see that AI is the overall field. Okay, machine learning is a part of it, and deep learning is another part of it. Okay, now back to the topic. So Java is another general language where you can do multiple range of application using Java. Okay, you can do the visual work, you can also develop desktop application, mobile applications, okay, and so on. So we always try to learn, or always try to use a programming language that is more general, okay, so that can be used in multiple domains. But this is a small criteria, because sometimes the uh, developers, they only focus on the application. It doesn't matter whether it runs on multiple platforms. Okay, whenever you're developing a website, your focus is the website. So this is not a big criteria, but this sometimes helps. And then finally is well definedness. So what does this mean? That the programming language that you will use is actually well defined, it's complete, it is precise. Different There are many other programming languages. Even you can create a programming language, but that programming language will be evaluated based on this criteria: whether your programming language is readable, whether your programming language is writable, whether your programming language is portable, whether it can be run on multiple platform, whether the programming language is general, that means it can be used in different types of domains, whether for doing simple applications or web applications, uh, or research and so on. And whether your language is well defined, that means all the structures, okay, all the completeness are specifically defined, okay, whether they are maintained properly, whether there is any bug to the programming language, so on. Okay, so these are the criteria that we have for a programming language. And the last one is sorry, two more remaining, that is cost and reliability. Now the cost one is very easy to understand, I think. So whenever you're developing a programming language, there are 6 types of cost related to it. The first one, training programmers to use the language. So how much time it actually needs the programmers to learn the language, that is also a part of the time. So there are some programming language were very easy to learn. Okay, so their cost will be less. I'm not talking about other criteria, whether the programming language is a readable, writable. No, I'm just talking about the cost, whether the programming language is easy to learn or not. Okay, so some of the programming language, they're very easy to learn. Okay, so they will get, their cost will be less. Okay, then writing the programs. So for how much time you need to write the same code into, let's assume, machine code and C code. Okay, so if you're using the machine code to write a simple function that will print something, you might need 5 minutes, and for the C program you might need 1 minute. So we can say the cost is less in C program. Same way we can compare between C, Java, C++. Okay, so we will write the same program in C, C++, Java, Python, and we'll see which one takes less time. So the one that takes less time will have the less cost. Then the cost of compiling the programs. So after you are done, whenever you try to compile, how much time it needs for your computer to translate the code, that will be the part of the cost as well. And then after the compilation is done, how much time it needs to be executed. So it happens that many people actually create many programming languages that are actually used as a normal API as intermediary. That means they are programming languages. They don't the compiler don't translate the code directly. The compiler first translates the code into intermediary language, let's say C. Okay, so whatever code you write in your programming language, that will be translated to C, and from C it will be translated to machine code. So what you are doing, you're using C programming basic structure as a intermediary. So in that case, your executing or compilation time will be much higher, because you're not directly doing that. Okay, then is language implementation system. So whether you're for your programming language, or the programming language that you're trying to use, they actually have free compilers to develop the system or not. Okay, finally the reliability that we will discuss in the next class. So whether the reliability of the programming language is high or poor. Okay, so if there is a poor reliability, that means your program cannot be easily reliable, and it sometimes crashes. Okay, in that case it will get, the cost will be higher. And lastly, the maintaining the programs. So maintaining means that after the program is done, there might be some bugs in the program. You might need to change the specifications. And at the same time, what might happen, that whenever you are developing a project, the overall modules, some modules need to be replaced. Okay, so in short, even after you have developed the project, there might be a scenario where you need to change the code. And if a programming language helps you to instantly identify bugs, or instantly identify where the program error is, or what module needs to be changed, in that case we say that maintaining the program is much easier. So To define cost, we start with training the programmers. Okay, so how much time you need to learn the programming language. To learn machine code, you might need 1 month. To learn C, you might need 3 months. So in that case, C is a more costly programming language. But then we go to the writing the programs. Okay, so you see, writing the program C is very much easier than machine code, so C is less costly. The compilation process of machine code is much faster than any other programming language, because it's almost in the machine code, right? So it doesn't need to be translated to machine code. But in the compilation program in C is much higher, because you need to be, each line of the code needs to be translated. So machine code wins in the compilation part, machine code wins in the executing part. So you see, machine code is less costly. Then availability of free compilers, that's where also the machine code wins. Then reliability, machine code is also more reliable, but C also has some features. So you can say the both are same in this case. Okay, it depends on the coder. So if the coder is same, they can do the more reliability in the both languages. Then maintaining the program, machine code is much higher. So after consideration of all these factors, okay, they actually decide which programming language to choose in terms of cost. Now, the comparison again from between C and machine code actually seems very difficult, because very seems very straightforward, because obviously the machine code is, we know the C programming will win. But when we do the comparison, okay, we also have to do the comparison in terms of C++ and Java. So if you want to compare between these programming languages, okay, just do the same thing for 3 programming languages. You will easily find out which one is more costly. Just the difference is you cannot know the timing, okay, because some the timing to train the programmers, okay, it actually depends on a person to person. So for example, there are 31 students here. Okay, so if I all give you a time to learn a programming language, okay, it depends on you, how it depends on your personal capability of how fast you can actually learn the overall languages. So this is a very complicated way to analyze the cost. So sometimes it's not dependable, but still we can find a workaround to